What if there existed a realm beyond our understanding, a fourth dimension? Would you dare to explore it? Let's start by discussing what we already know about dimensions. A dimension, in the simplest of terms, is a measure of spatial extent. Now, this might sound a bit complex, but bear with me, it's easier than you think. Consider a straight line. It has only one dimension, length. It's the simplest form of existence we can imagine. Now, if we add another line perpendicular to the first, we've entered the second dimension, a plane. This plane has length and width, but no depth. It's like a sheet of paper or a perfectly flat screen. Now, add another perpendicular line, one that goes up and down. We have now entered the realm of the third dimension, a space. This space has length, width, and height. It's the world as we humans perceive it, where everything from the smallest atoms to the largest galaxies exist. But what if there was more? That's where the concept of the fourth dimension comes in. It's a theoretical concept that goes beyond our three-dimensional understanding. The fourth dimension is often described as time, but it can also be considered as another spatial dimension, one that we can't perceive or comprehend with our current understanding and perception. Imagine a cube, which is a three-dimensional object. Now imagine that cube changing over time, like melting into a puddle. If you could see the cube at all points of its existence at once, from cube to puddle, you'd be seeing in 4 dimensions. It's mind-boggling, isn't it? The fourth dimension is a concept that has fascinated scientists, mathematicians, and philosophers for centuries. It's a subject that challenges our understanding of the world and the universe, pushing the boundaries of what we know and what we can imagine. If you're intrigued by this, stay tuned as we dive deeper into the sea of the fourth dimension. Imagine a universe beyond our own, a universe of 4 dimensions. This is not a realm of science fiction, but a concept deeply ingrained in the study of theoretical physics. To embark on this journey to the fourth dimension, let's start with the one we're most familiar with, space-time. Here we live and operate in 3 dimensions, height, width, and depth. We move forward, backward, left, right, up, and down. But there's another factor we experience constantly, yet can't control or maneuver through: time. This is where the fourth dimension comes into play. You see, time is not just a ticking clock or a turning calendar page. In the realm of physics, it's regarded as a dimension, just like the 3 spatial ones we know so well. It's a concept we owe to a brilliant mind from the early 20th century, a man named Albert Einstein. Einstein's theory of relativity shook the scientific world, suggesting that space and time are not independent entities but interwoven into a 4-dimensional space-time continuum. According to this theory, the fabric of space-time bends and warps around massive objects, creating what we perceive as gravity. The fourth dimension is not an alternate reality or a distant universe. It's here, intertwined with our everyday lives. We exist within it, even if we can't perceive it in the same way we perceive the 3 spatial dimensions. It's like a river, constantly flowing, carrying us along its course. And while we can look back at the past and anticipate the future, we can't step out of its stream. Physicists are still grappling with the complexities of the fourth dimension, but the concept has already revolutionized our understanding of the universe. It's a testament to the human spirit, our innate curiosity, and our quest to understand the world beyond the limits of our senses. So, the fourth dimension could be right here, right now, just beyond our perception. This journey to the fourth dimension is not a physical voyage, but a mental expedition, a leap of comprehension into the complex fabric of spacetime. From the realm of physics, let's step into the world of mathematics to understand the fourth dimension better. Mathematics offers a unique perspective on the fourth dimension. It's a realm where we can move beyond our physical limitations and explore concepts that are, quite literally, out of this world. One such concept is the tesseract, also known as a hypercube. Imagine a cube. It's easy enough, right? Now try to think of a cube in 4 dimensions. Not so straightforward, is it? Well, that's where a tesseract comes in. A tesseract is essentially a cube in 4 dimensions. It's a shape that we can't physically see or touch in our 3-dimensional world, but it exists mathematically. To visualize a tesseract, let's start with a point, a 0-dimensional object. Extend it in a direction and you have a line, a 1-dimensional object. Extend the line perpendicular to itself and you get a square, a 2-dimensional object. Extend the square perpendicular to itself and you have a cube, a 3-dimensional object. Now if we could extend the cube perpendicular to itself, we would get a tesseract, a 4-dimensional object. The concept of a tesseract or hypercube allows us to theoretically understand and visualize the fourth dimension. It's like a cube, but it extends in another direction, a direction that's not up, down, left, right, forward, or backward, but somewhere else entirely. It's a direction that we can't comprehend in our three-dimensional world, but it's there nonetheless in the realm of mathematics. Exploring the fourth dimension mathematically opens up a whole new world of shapes and possibilities. It's a playground where the rules of our physical world don't apply, where shapes can be inside and outside of each other at the same time, where objects can be in multiple places simultaneously, and where straight lines can be curves and vice versa. In the world of mathematics, the fourth dimension is a playground of mind-bending shapes and possibilities. The fourth dimension isn't just a concept for scientists and mathematicians, it has also captured the imagination of artists and writers. Imagining the fourth dimension is a challenge, but this hasn't stopped it from being a recurring theme in popular culture. Its elusive and enigmatic nature has made it a fascinating topic to explore in various forms of media. In the realm of literature, for instance, the fourth dimension has been an intriguing plot device. One of the earliest examples is Edwin Abbott's Flatland, a satirical novella that uses the fourth dimension as a metaphor for societal hierarchy. More recently, Madeleine L'Engle's A Wrinkle in Time introduces the concept of tesseract, a means of traveling through the fourth dimension. Moving on to the silver screen, the fourth dimension has been a cornerstone in many science fiction movies. A notable example is Christopher Nolan's Interstellar. The film explores the concept of a tesseract, leading to a mind-bending interpretation of time as the fourth dimension. Art, too, has not been left behind. Salvador Dali, the surrealist painter, often depicted four-dimensional figures in his works, most famously in Crucifixion, Corpus Hypercubus. His unique interpretation of the fourth dimension was a way for him to visualize and understand spiritual matters. Even in video games, the concept of the fourth dimension has been played with. Games like Megakure allow players to navigate four-dimensional space, offering a unique interactive way to explore this concept. Music hasn't been left out of the mix either. Bands like Tool have used lyrical themes and album art to explore concepts related to the fourth dimension and time. From literature to film, art to video games, and even music, the fourth dimension has proven to be a wellspring of inspiration. These popular culture references serve to highlight the allure and mystery of the fourth dimension, reflecting our ongoing fascination with understanding the universe beyond our three-dimensional perspective. From science to art, the fourth dimension continues to inspire and challenge our understanding of the universe. So, what have we learned about the fourth dimension? We began our journey by tackling the dimensional dilemma, attempting to unravel the layers of complexity inherent in our understanding of dimensions. We discovered that dimensions are, in essence, different perspectives or ways of looking at the world. From the one-dimensional line to the two-dimensional plane, and then to our familiar three-dimensional space, each dimension adds a new layer of depth and complexity. Then, we embarked on a journey to the fourth dimension, a concept that pushes the boundaries of our understanding. In theoretical physics, the fourth dimension is often interpreted as time, which weaves itself into the fabric of space-time, a four-dimensional structure integral to Einstein's theory of relativity. This understanding of the fourth dimension suggests that it is not merely an extension of space, but a different concept altogether. Our exploration then took us to the realm of mathematics, where the fourth dimension takes on a more abstract form. Here it is conceptualized as a spatial dimension similar to length, width, and height, but in a direction that is incomprehensible to our three-dimensional perspective. This mathematical interpretation of the fourth dimension has been instrumental in various fields, from theoretical physics to computer graphics. Finally, we delved into the portrayal of the fourth dimension in popular culture. We saw how it has been used as a storytelling device in science fiction, a tool for exploring concepts beyond our understanding. From the mind-bending narratives of Interstellar to the quirky adventures of Doctor Who, the fourth dimension has found a home in the imaginations of writers and audiences alike. The fourth dimension, a concept beyond our understanding, yet integral to our universe. As we continue to explore this fascinating concept, who knows what discoveries await us? After all, the journey of exploration is just as important, if not more so, than the destination itself.